Hello, today I'm talking to Steve Daley. That is Professor Steve Daley at the University of Southampton in the UK. He is also CEO of Clantect Limited. They produce the Clantect MDT or motion detection technology, more commonly known as heartbeat detectors, used for finding clandestine people hidden in vehicles. The new product is the MDT Mobile. Welcome, Steve.
Good morning, Tony. Good to see you.
Good to see you too. Now, before we go on, could you give us a little background to your scientific background into this field?
Of course. As you mentioned there, I'm a professor at the University of Southampton, but more importantly, I'm a professor at the Institute of Sound and Vibration Research, which is located at the university, which is a unique grouping of academics and researchers dedicated to the science of sound and vibration. And we're just coming up for our 60th anniversary, so we're well established. I've been working in this field for 40 years since I did my PhD in suppression of vibration. And so you could say that I know quite a bit about sound and vibration, and my particular specialism is signal processing techniques for suppressing noise and vibration. I personally was approached a few years ago by UK Border Force that were having some issues, significant issues with legacy machines and heartbeat machines, as you say, what we would call the first generation of machines. And their particular issue is that being Border Force, machines were located in very busy port environments, and the problem they were getting with the machines were that the background vibration from passing traffic that rarely ceases was causing them to have a lot of false positives, so that they would be continually searching vehicles when they didn't need to, and so that the machines became virtually unusable for them because of the way that they responded to background vibration in these locations. And so they called me in initially just to see if I could give them some advice as to how they could use them differently. And it occurred to me when I was working with them that we could develop a machine that integrated our signal processing know-how, and particularly our noise reduction know-how, into the machines. And so we developed a prototype that was taking in a vibration from the ground as well as vibration from the vehicles, where we could use our algorithms to determine whether vehicle vibration we're measuring was actually caused by people inside the vehicle or was actually caused by passing traffic and other disturbances such as machinery operations. So we first then developed a prototype that they used for some months that they really liked, and then ultimately we ended up producing many machines for them in a framework agreement that we won in 2016, initially through the university, but now through a spin-out company, which is Clantect from the university. So we still have all the support and scientific support from the institute, and I remain a professor, as you say, at the institute. So that's how we came into being, and we're now selling those machines worldwide.
Where else are they sold, can I
ask? Across Europe. So we have a framework agreement with Frontex, for example. That's the European border agency that that supports the Schengen region. We have them in the Middle East, but also it's not just borders, they're also in prisons. So they're in prisons in places like Poland and, as I say, in the Middle East, in the UK prison estate, and we also have machines in borders in Turkey. So we've pretty got good global coverage.
Okay, so let's come on to MDT Mobile. Now, what is new and significant about this particular piece of equipment?
So can I share an image?
Please do.
Shows you, so I can talk around the image. So this is the product, and the difference in the product is that this is a highly portable and highly mobile unit. And as you can see, all the system is based around, on bottom right now, our original systems, I should say, were mainly desktop, sort of desktop PC type size, basically a panel PC, industrial panel PC in a ruggedized enclosure. So although they're sort of portable, not quite as portable as the machine that you can see in front of you, which consists of a laptop with a detachable tablet type PC. You can see this chap on the left of the image here testing a vehicle with just the tablet part of it, which makes it very, very mobile. And it all fits in, and so the system requires just the tablet PC, which has all the functionality of our desktop machines, and 4 wireless sensors. So it's entirely wireless, no cables involved, which means it's very portable and therefore can be used in patrol cars for ad hoc checkpoints. Because today, obviously, it's not just the border agencies that are involved and wanting to look at clandestines inside vehicles, but covers a whole load of law enforcement agencies that have to be a bit more mobile and do have ad hoc roadside checkpoints. So the whole point of this is that it's a very mobile system that is very quick and easy to set up, and as I say, is entirely wireless, so very easy to use.
And what is it? I can see at the image in there, you've got some sort of stand-up device there by that vehicle.
So the central image you can see there is our unique tuned wind frame. So obviously, when you go to ad hoc checkpoints, a lot of the borders tend to have enclosed shelters where you can use the machine in an enclosed area and protect it from wind. and obviously, in an outdoor arena, such as you would get with an ad hoc roadside check, is that you can't protect the vehicle from wind. And what that means is that you get an extra excitation of the vehicle. So the vehicle doesn't vibrate just because of people inside it. It vibrates because of passing traffic, also wind created by passing traffic, but also wind, of course. And so we also need to be able to extract the effect of the wind from the measurements we're taking from the vehicle. And to do that, we developed, as I say, this unique wind frame that you can see in the middle here, that is designed to vibrate in the same way, respond in the same way as a vehicle does to wind. And so it allows us a very good measure to able to process the signals and remove the effect of the wind and maintain very high accuracy in an outdoor environment, which makes us very much unique in that we can operate in these outdoor environments and still maintain accuracy, whereas the legacy machines could fail to operate accurately. That, as I say, they either give false positives, or you have to set the machine thresholds such that you're going to miss clandestines inside.
Okay, so effectively what you're saying then, for vehicle checkpoints, etc., without a wind frame or that you've developed there, without that type of device, it's not really going to be working properly. That's
true. That you just can't function without it. So there are always disturbances of some form, as I say, in an outdoor unsheltered environment. That's worse. And as I say, it's not just when there is wind present, there is passing traffic causes pressure waves that affect the vehicle and creates additional vibration. So you just can't function accurately with this type of technology without a sensor of this type, and more importantly, the signal processing and the advanced algorithms that we've developed at the Institute that go with that.
Okay, fantastic. Also, how do you share information with this system?
In terms of what respect? You mean?
Is it networked? Is it?
It can be. So we have different options on the machines. The basic way of getting information off the machine is just through a USB that takes the data. So each test that is undertaken on a vehicle is logged in terms of the results, the time of day, the operators, the vehicle registration number, and any other comments that the user wants to put in. And that can be taken off in a spreadsheet form for later analysis of data and also housekeeping back into the performance of the machine. The simplest way of getting that off is via USB, but we also have networked solutions, our Clantect software that allows operators in some remote locations, so if there's a border agency, for example, with several machines across a country or across several countries, in the case of Frontex, for example, then they can bring the data that I just talked about from each of the machines back to a central location on the laptop, and also be able to view the screen remotely. So if there's any sort of uncertainty around results, a central operator or experienced operator can advise. It also allows us access to the machines, should the agency want us to do that, in order to update the software and do fault finding if there's any issues, and remote diagnostics. So yes, we do have that capability as well.
Right, fantastic. Okay, thank you very much for your time, Steve. That was really interesting. Thank you and goodbye.
Thank you, Tony. Good to see you again. Cheers.